Understanding integral notation, something I think would be super beneficial right before the test especially. So I'm going to walk you through a few possibly misconceptions here. Let's go ahead and allow the horizontal axis to be t for time, and let's just say, for sake of having some concrete numbers here, let's say time is in hours, and then let's just say the vertical axis would represent the position s of t or x of t, and this would be, let's say, in feet, miles. Okay. All right, and then we'll go ahead and just draw just some random position function s of t, and then let's see here. We know that when we integrate, we go one direction, but when we differentiate, is what we're going to go back to here. We differentiate, what we're really finding is the rate of change of a function at a particular point. And so let's zoom in on this little spot right here on the graph, and let's say right there what we want to know is the rate of change, or the slope right there. So let's call that the change in y over the change in x. So we're going to estimate the slope right there. And the slope, we know that to be equal to the change in y over the change in x. Now I'm not so interested in what the numbers are, but I'm really interested in what the units are. Okay, so we already know this, that the rate of change of the position would be the velocity, so we're going to call it the velocity at that particular point. But again, I'm not interested in so much in the numbers as in the units of measure. So the change in y, would be a number of miles. So the change in y would be in miles, and the change in x would be in hours. That's why we get velocity. So to summarize, therefore, velocity is in miles. Sorry, my writing is horrible right now. My arm is still in a sling. Miles per hour. Okay, so that's what we get. We get velocity is in miles per hour. Okay, so let's go on to the next one. Let's take the miles per hour and let's plot that. So we still have t in hours. Okay, and then we have v of t in miles per hour. Okay, so let's draw it in a different color. So this is their v of t graph, and again we're interested in the rate of change of the position, or the velocity function, and the rate of change, the vertical change would be change in y, and the horizontal change would be change in x. Okay, so the same thing we just did. The slope is the change in y over the change in x. We know that the slope of the velocity is the acceleration. And the change in y, again, this is the vertical change. But we said that the vertical change for the velocity graph is in miles per hour. So we're going to list that as miles per hour. And the horizontal change in x, change in the horizontal direction, would be in hours. Okay, so that's why we get, I'll put that down here at the bottom, so we get miles per hour. So I know some of you, that's, why I always get that question, why is acceleration in miles per hour? Well, this is why. Because the change in y would be miles per hour, and then per hour. So we have miles per hour, or you look at the fraction, miles per hour times 1 over hours. So divided by hours, or times 1 over hours. So we get miles per hour squared, or miles per hour per hour. And that's why acceleration is in miles per hour per hour. Okay? So that takes care of going from position to velocity to acceleration. And check the next video for how we integrate and what we get when we integrate.